let's try to solve another Leetcode problem. 622 design a circular queue. So for this problem, we are giving a class my circular queue, and we cannot use the built-in data structure like the queue in Python. So for this problem, we can use an array or we can use a linked list, but I prefer to use array because this is just easier to solve. Yeah, so for this problem, if we are going to design a circular queue, we need to define we're gonna be the front pointer and we're gonna be the rear pointer. So for example, from the beginning we're gonna design this gonna be the front and this gonna be the front and this gonna be the rear pointer. It's gonna be at the same position. So for example, it can be 0 or yeah. So this is just from the beginning. So what is the meaning of the front pointer? So front pointer, it means the front element at the head of the queue. Yeah, so this is the front pointer. So for example, if we are going to insert an element for example, we are going to insert an element 0, the front pointer will be the same, but the rear pointer will be here. So this is going to be the rear pointer. So continually, if we were to insert another element, maybe we're gonna use in queue, so the rear pointer gonna be here. Yeah. Of course, we can also use the queue. So if we use the queue, so the front pointer gonna be here. Yeah. So this is the idea, but this is a circular queue. Normally, the head should be connected with the tail, but as we are using an array, we're going to use a modular to check such kind of cases. So basically, this is depending on how we're going to design is empty or is full. Yeah. So as the front pointer and the head pointer will be at the same position from the beginning, and for this circular queue, for the array, the space gonna always be k+1 because for this rear pointer there's no element. So for example, here inside the rear pointer there's no element. This is why we're gonna design the capacity to be k+1. Yeah. So in this case, basically we need to check how can we design this is empty. So if the front pointer equal to the rear pointer, so basically means the queue is empty. So in which case it is full. So this is the front pointer and this is the head pointer. So if the rear pointer goes to the end, so basically this means the queue is full. Yeah, it's full capacity. So this is full. Now let's just first to write it's empty and it's full. So we're gonna define the self.front equal to self.end gonna equal to, yeah, I forgot how can I make it smaller. Yeah, how can I make it smaller? Yeah, let me just try to make it smaller. So the self.front gonna equal to self.add gonna equal to 0 and self.capacity. So we're gonna prepare a capacity gonna equal to k+1, and we need to prepare a array. So self.array gonna equal to 0 for I in range self.capacity. So this is the definition. So from the definition, we needed to know what is is empty. So it's gonna be the self.front gonna equal to self.end. So this means from the beginning, the circular queue is empty. Yeah. So if we insert or include any element inside it, so it is not empty. So how can we check if it is full? So it's gonna be the self.rear +1 modular the capacity. Yeah. So we're gonna use it to modular self.capacity if it is equal to self.front. So basically this means yeah, so this means it is full. So for example, this is the front and this is the rear. So for example, this is the index 0, this is the index n minus 1. Yeah, so this is real n minus 1 plus 1, it's going to be n modular the capacity is going to be n, so it's going to be 0. So this means it equal to self.front, so basically this means it is full. Yeah. Now let's just write some easier ones first. So what about self.front? So if self. Is empty, which means there's no front, so we're gonna return -1. And similarly for the rear, the check is gonna be the same. Yeah. So if self dot is empty, we're gonna return a -1. So otherwise, so we're gonna find the front element. So get the front items from the queue. So it's gonna be return self dot array with the self dot self dot front, which is gonna be this element, right? Yeah, because we just need to find this element. Now what about the self dot rear? So we're gonna return self dot array with the self dot rear, but it is not this element, because according to our design, so the element should always be the element before the rear pointer, so it must be one position before it. So it's gonna be self dot rear -1. Yeah. But as it is a circular queue, we need to use a capacity. So it's gonna be on self.rear -1 plus self.capacity modular self.capacity. So this is gonna be the rear. Yeah, because in some case maybe the rear is here. So what's gonna happen? Yeah, so the rear gonna be here, so the front may be here. Yeah, because this is the array, so this is the rear, this may be the front, and now these areas will be some of the elements. Yeah, so this is why we're gonna use a rear -1. It's gonna be one element before it. Yeah, if there's some element, and then we're gonna plus a self.capacity modular self.capacity. Now we are going to check this in queue and dequeue. So if the self dot is full, so this means if we cannot put anything inside, so we're gonna return a false directly. Otherwise, this means the queue is not full. Definitely we can put some element in we can put some element inside it. So self dot array with the self dot front gonna equal to this value, and we're gonna return true. Yeah, but we cannot use this front. Yeah, let me think. So currently, yeah, let me just make a better drawing. So currently, this is the front, and this is the end as well, and it is not full. So we're gonna enqueue a value. So for this enqueue, yeah, if we were to use enqueue, we're gonna add a value at the tail, at the rear. If it is the queue, we're gonna pop a value at the front, right? So this means this is the rear. Yeah, so we're gonna use the self.rear. So first of all, we're gonna record this value. So self.array with the self.rear gonna have this value. And then we're gonna update the self.rear. Gonna equal to self.rear plus 1. And we need to modular self.capacity because it is a circular cube. Yeah, and similarly for the decay. So for example, this is element 0, and currently this is rear, and we want to pop out an element at the head, at the front. So for this 0, we want to decay with this 0. So in this case, the self.front should plus equal to 1. So let me just copy it. So if it is empty, we're gonna return false, because if it is empty, we cannot do anything. Now, self.front we're gonna update the self.front. So self.front gonna equal to self.front plus 1 and modular the capacity. Self.capacity. Yeah. So this is decay. So decay is always from the front. So we take out this element and F gonna be here, and this is F, and finally we're gonna modular the capacity. Yeah. Now let me just run it to check if this is okay. Rear, I did something wrong with the rear. I didn't prepare this. Should be the rear, not the end. This is the rear. I will use the rear, not the end. Yeah. Now as you can see, it works. Now let me just submit it to prove that it can pass. As you can see, it passed all testing cases, and it's pretty fast because we are just doing a design of the circular cube. So the time complexity, it doesn't matter, because for in queue the queue that is always O1, and earning from the init it takes some time, but that is ON. And for the front rear, it's empty, it's full, it is always O1. Yeah. The important thing about this problem is that we're gonna use an array, and the front and the rear pointer will be at the same position from the beginning. It's gonna always be pointed to 0, and the front pointer means if we want to in-queue an element, we're gonna always put the element at the rear pointer. Yeah, for example, this position, and then the rear pointer gonna be plus 1 to the next position. Yeah, if we want to use the queue, the front pointer always be shifted to one position to the right side, but don't forget to modular the self.capacity, because this is a circular queue. Yeah, so in a lot of positions we just use this modular, the self.capacity, because this is really important. So if we don't plus this one, let me check if it is okay. Yeah, because in Python maybe it works. Yeah, as you can see, it also works. Yeah, because basically if we don't plus this one, it is still works for Python, but for other languages it didn't work. So that is why we keep this plus this self.capacity. I think that's all about it. Thank you for watching. See you next time.